Hello and welcome. The title, my favorite differential equation. Here it is. Y is equal to x dy by dx plus e to the power of dy by dx. I wish I had written this question, but it wasn't me. Where is it coming from? I think I picked it up on a discussion in a mathematical forum, and it's actually once you see what Mike needs doing in there, it's actually not that difficult. The techniques involved are kind of like maybe a little bit advanced in terms of thinking, but I think somebody with good grounding in mathematics and further maths perhaps will be able to follow this particular solution. It's actually very, very unusual. It's not something of the standard techniques on differential equations you're likely to come across, like some kind of substitution or anything like that. So let's get started with this. So what is the problem with this particular differential equation? Well, quite clearly the problem is this differential coefficient, which is e to the dy by dx. So where we will start with something like this, we're going to start by differentiating the differential equation across with respect to x. So diff with respect to x. And the question is, pardon me, why do I want to do something like that is the question. Can you actually see what will happen when you do this particular technique? Okay, let's have a look at it. First of all, observe what's going to happen when you're differentiating this term, and observe what's going to happen when you're differentiating this term. So dy by dx, remember I'm differentiating with respect to x. This is a product, differentiate the x, 1 times dy by dx, plus the other way around. So we have, of course, x, differentiating now this with respect to x, of course, is going to go second derivative, and now we have a chain. Exponential will differentiate to itself, so e to the dy by dx times the differential of its argument, which of course is second derivative. Rather nice. Okay, so we got in this particular case something like that. And we have a second derivative coefficient, which I can factorize, and I get x plus e to the dy by dx is equal to 0. Of course it's 0 because I cancelled this, and just in case you're just wondering what's going on. Okay, I can split this differential equation. Either the second derivative is 0, in which case the first derivative will be some kind of constant, in which case your constant, your first, your function, if you want, could have the form cx plus d. That's by integrating twice that. But what I want to do with this, this is just a mess. It looks like I've made no progress. But if you look carefully at the original differential equation, and you rearrange it, this quantity is in fact y minus x dy by dx is equal to 0. So I'm going to split this particular now differential equation into that is equal to 0 and that is equal to 0 and hope for the best. So first of all, let's do this bit here. The second differential coefficient is equal to 0. It means that the first differential coefficient will be some kind of constant. Call it capital A, which means your y could be that. That will certainly, irrelevant what that is, that will definitely balance the equation. So the next thing to do is to think about now this differential equation. I did say we don't need further maths. I hope might need further maths. I don't actually remember. It might be having integrating factors and all sorts of other little things. So let's have a look. So I dealt with that. So let's just copy this at the very top. And we've got, of course, x plus y minus x dy by dx is equal to 0, or x dy by dx minus y is equal to minus x. My brain is misfiring now. Is equal to x. Let me just think about this. Now, I move that to the right, it goes plus. I move that to the right, it goes minus, and I left the x on the left. So this appears to be okay at the moment. So it does require an integrating factor. So first of all, let me just divide by x, because of course, in order to find integrating factors, we need to have it in this particular form, is equal to 1. Integrating factor e to the integral of minus 1 over x dx, which of course is e to the minus log x, which is of course putting x to the minus 1 is going to be 1 over x. So this now, if you times it by 1 over x, it becomes exact. So d by dx of y times 1 over x is equal to 1 over x, y over x. So this is all further maths. I did say, I didn't realize, actually I didn't remember that this question does require, in fact, a little bit of further maths knowledge when it comes to this kind of stuff. So y over x is equal to this. Y over x is the log of x. Shall we put mods there? Let's put mods. Pardon me. Plus some kind of constant. So we have finally y is equal to x times, what's happened to the pen? Just something probably doesn't like it on the surface there. Y is equal to x log x plus some constant x. So in fact, this is another solution. So our y is either that or that. And we can actually write this. I don't know if you're familiar with this kind of technique. We can write this particular solution compactly. So rather than saying the solution of this differential equation is y is that or that, we can actually write it as follows. Y minus ax plus b. There's no plus b. Could call it minus, but that, it hardly matters. I mean, whether you call it minus there. But I'm doing it like this so you can actually see. So I'm looking at this. So I move all things to the left, and then the same thing. Y minus x log x minus cx is equal to 0. So either this is 0 or this is 0. So if you think about what that actually says, if this is 0, this is 0, which means that is a solution. And similarly, if this is 0, then you can move that to the other side. You obtain this particular thing. But of course, A, B, and C are totally arbitrary. So there's no need to keep minus, minus, and a minus on this one. Therefore, the solution, so I'll just write in a different color pen. What pen shall I use? Some nice color. We got a red pen. Therefore, the solution will be y plus ax plus b times y. Let's put the that's a cx in there. So so y plus cx minus x log the modulus sign there is equal to 0. So we can actually have the solution in this particular form. And this is a very, very unusual question. Very much off the beaten track. I mean, you're not likely to see something like that. But as I said, I'll pick this question in some kind of discussion, some kind of forum. It's for the connoisseurs really, but highly enjoyable and not that difficult. You do require as further maths, unfortunately, to follow, but highly satisfying. Okay, I'm signing out. I'll see you real soon for more maths videos. Bye for now.